Hi guys, Ms. Viramontes here. Hopefully everyone is doing okay. I know it's just been really crazy, but I did want to just go ahead and upload your notes this time around. Not doing a live session, but I will do one just to check in, see if anyone has any questions, possibly Wednesday. So look out for that, okay? I will send out a reminder and maybe a poll to see if you guys are still okay with the same time, 12 o'clock like last time. Again, it'll be really quick. I think the last one went on for a little longer than I anticipated. Okay, so the unit circle and trig values, these notes, I do want you to copy them on page R78. So please make sure to do that. Okay, so the next thing that I want you guys to be able to do utilizing the unit circle is to find the exact values of a trig function. So I'll give you examples in a second. But to find the exact value of a trig function, you will need to use a unit circle. So hopefully you guys already uploaded the last assignment on the unit circle where you guys had to use the game to try to figure out what some of those values were. So definitely try to make sure that that gets done before you do this. Now, in order to do this, it is going to be a lot easier if you know how to use the units, if you memorize unit circle. However, if you don't memorize it, there are ways around it. I mean, it takes a lot more work, but like like anything, there's a way around it. Sorry, guys. Okay, so here's an example. I'm going to give you guys 3 examples. The instructions say to find the exact value of each trig function. Now, notice that whenever they're talking about exact values, they are talking about, what do you call it? I'm sorry, when they say exact values, they want fractions, right? Because decimals, as you know, are not exact values. Those are rounded values. So exact values, you want to leave them as fractions. All right. So the first example that I have for you, right here. Thank you, Mama. No, Kobe, get down. Get down, Kobe. Maybe you should can you take this back and, oh, yeah. Okay, thank you, Mama. So, the first one is sine of 135 degrees. So I'm going to show you both ways how you could do it just by using a unit circle. And I did give you guys this printout. So you guys can use this as your reference. It is posted on Schoology. So the sine of 135 degrees, 2 things that you have to pay attention to. Pay attention to this, right? When the trig values are actually positive. So remember we said all students take calculus and obviously they're reciprocals, right? And then you also have to know this. We talked about this last time. We said how we did this in the last lesson, how sine of theta was equal to y, cosine of theta was equal to x, tan of theta is y over x, and these are obviously the reciprocals as well, right? So you'll see that y, the cosecant of is actually 1 over y, right, which is the reciprocal. All right, so pay attention to that. All right, now I'm going to use this using the unit circle. So it's a sine of 135 degrees. I know that sine of 135 degrees is right here, right? Now, here's what I have here. I have an x coordinate and I have a y coordinate. Remember that the sine of theta is just y. So for this one, sine of theta, I know is going to be square root of 2 over 2. So I know that this one right here is going to be equal to square root of 2 over 2. Now, again, like I said, if you know the unit circle, this is going to be pretty easy. But if you don't, let me show you what you would have to do. Okay, so you would have to kind of utilize your reference angles to do that. So sine of 135 degrees, what I would do, I would go ahead and pretend to draw like the unit circle, right? And if I have 135 degrees, I know that it's going to be in the second quadrant, which is going to be right there. Yeah, give me a second, baby. Baby, can you give me that paper right there, please? Hurry, hurry, hurry. Thanks, Mama. Okay, so again, you know that it's sine of 135 degrees. Now, what you would have to do, you know that what you want to figure out is what the coordinates are going to be right here, right? In order for me to do that, I am going to go ahead and drop an altitude. Okay, because if I drop the altitude, then I know that that's going to be a right angle, and I have to figure out what this angle is, hence our reference angle, right? Because we already know that this is 135 degrees, so we have to figure out what this angle, which is the reference angle for 135 degrees. And I know in order for me to do that, I would have to get 180 degrees because the whole thing's 180. And I would have to subtract this chunk right here, which is 135 degrees. So that is going to leave me with 45 degrees. Special right triangles, right? 45, 45, 90 triangle. All right, so now that I have that, let me label a couple of things that I know. Like, for example, I know this is a radius, so I know that's going to be 1, right? And remember, this is a special right triangle. Let me try to, well, maybe I can still do it here. I know that this is a special right triangle. It's a 45, 45, 90 triangle. So I know that normally this would have been S, that would have been S, and this would be equal to S times the square root of 2. Now I have to find out what S is in order to figure these out. So I like this equation right here. I'm going to use it to go ahead and find out what S is. 1 is equal to S times square root of 2. I'm going to go ahead and divide by square root of 2. And that leaves me with S is equal to 1 over square root of 2. Uh-oh, there's a problem here. I have a radical in my denominator, so I'm going to go ahead and rationalize that. So I'm going to multiply that by square root of 2. So square root of 2 over square root of 2, which is the equivalent of 1, right? So when I do that, I'm going to get left with S is equal to 1 times square root of 2 is square root of 2 over square root of 2 over times square root of 2 is 2. So that's what this is going to give you. And you know these are both the same. So now you know that this value right here, which is going to be square root of 2 over 2. And this value right here is going to be square root of 2 over 2. Now, I want you to think about this for a second because you have to think about your signs, right? If this is the, again, we're on the coordinate plane. Now, this value right here, from here to here, is square root of 2 over 2. And this one right here is square root of 2 over 2. Now, which one's positive? Which one's negative? Well, you know this one's going to be the negative one, right? Because you start here, you're going to the left. So you know that this one's going to be negative, and that one's going up. So that's positive. Okay, so now we figured out what, again, this would technically be my X. And this would technically be my Y. Okay, so if I were to do this, I know that that what you want to get is the sine of 135 degrees, which would be the same thing from your reference angle. So remember that the sine is Y. So it would just be this right here, square root of 2 over 2. So you guys see it took a lot more work. It took a lot more work. But if you can just use a unit circle or try to memorize a unit circle, if we were in class, we would have had memorized this. But I know I have less control when you guys are away from me. But either way, here we go. Let's do another one. The cotangent of negative 300 degrees. Ooh, negative, right? So I'm going to go ahead. I'm going to look at my unit circle. Here I have, that's 0. I know if I was going positive, it would go in this direction, right? It would go counterclockwise. But if I'm going negative, it's going to go clockwise. So let's think about this. I want 300 degrees. So I know I'm at 0. That would be 90 degrees. At another 90, that would be 180. At another 90, that would be 270. And now I need 30 more degrees to make negative 300, which this would be 30 degrees. Okay, don't forget that each one of these big chunks here is 30 degrees. And each little increment here, those are going to be 15 degrees. So 30, so that's 30, 15, 15, 30, 30, 15, 15, 30. You guys get the idea. Okay, so like the bigger increments, the bigger angles, those are 30. The smaller ones are going to be 15. So back again, what I was looking for 300 degrees. That's 90. Go this way. That's 180. Go another 90. That's 270. Plus a 30 is going to be right here. So this is what I'm looking for. I'm going to use these values to find out the cotangent of negative 300. So I know I'm using these values right here. So remember the cotangent is x over y, okay? So the cotangent is x over y. So what I'm going to do, I'm going to get my x and I'm going to put it over my y, which is 1/2, right? And my y is over square root of 3 over 2. Beautiful. Now, you guys can go ahead. I'm going to just show you a little quick trick that one of my calculus teachers always showed me. If you want to, you could go ahead and write this over again, or you can do this in your head. Some of us are really good at doing this in our head, but you could just multiply this one with this one and this one with this one. This will give you the numerator and this will give you the denominator, okay, to divide that out. Now, again, you could have done 1/2 times 2 over square root of 3, which is going to give you the same thing. All right, so now I'm going to multiply 1 times 2. That's going to give me 2. So that's your numerator. And then 2 times square root of 3. Okay, do you guys see what I see? I see a denominator that is not rationalized. But first I can divide this out and just divide that out. So technically I'm left with 1 over square root of 3. And now I'm going to multiply by square root of 3 to both sides. I'm sorry, to both numerator and denominator. That leaves me with square root of 3 over 3. And that is your final answer, my friends. That is that one right there, square root of 3 over 3. Okay, that's the exact value of that. Let's try one with radians. Again, if you're using the unit circle, if you memorize the unit circle, should be a piece of cake. Tangent of 2 pi over 3. Well, what is 2 pi over 3? It is 120 degrees, right? So 2 pi over 3, the tangent is 2 pi of 2 pi over 3. We're going to use these order pairs right here, that order pair right there. Negative 1/2, and then square root of 3 over 2. So tangent, again, let's look here. Tangent says that I have to use y over x. So, okay, so again, I know it's going to be y over x, right? So 2 pi over 3. My y is square root of 3 over 2. Sorry. All over negative 1/2. Okay, so I know it's going to be negative because I'm dividing by negative, so I'm just going to put a negative. And again, multiply this one to this one. Use a different color here. So that would be 2 times square root of 3. All over 2. Let's simplify this guy. Again, you can divide this out. So you're left with a negative square root of 3. Does that make sense? Feel free. I'm going to go ahead and upload some questions. Again, please have these notes copied on page R78. These are the notes that you should have on there. I also want to see questions and summaries. So please, on the assignment where I upload this video, please make sure that you create questions and summaries for this video. And on the left side on L78, I'm going to assign some additional problems that I want you guys to follow through with, okay? All right, guys, have a great day. Stay safe, and I will check in with you guys later on this week. Bye-bye.